on the top. Have you got the slides?
Yeah, it's on. Yeah, it's all set up.
So true.
It's zooming in even.
You can put the slides up.
Yeah, we'll do it in a minute.
Oh no, this is going to be messy, isn't it? Sorry.
Transition.
Hooray. Hello, everyone. My name's Benji. I'm a member of the GraphQL Technical Steering Committee, and it is my absolute pleasure to welcome you today to the first London GraphQL Meetup of 2024. Hooray! So this is officially hosted by the GraphQL Foundation, and an event like this doesn't come together without some support. So let's have a thank you to all of these folks. We've got ChilliCream, who've provided Michael here, who's doing all the streaming for us. Thank you, Michael. We have GraphQL, who's provided myself. We have Guild, the events platform, who you may have all signed up for this event through. We have Hasura, who have paid for the food this evening. We've got Neo4j, whose wonderful offices we are in right now, and whose great hospitality we very much appreciate. And we have the Guild, who have been very instrumental in helping to organize these events across the world. And we have Laurin here talking from them today. Talk to you later. So, like all of the events that the GraphQL Foundation runs, we're governed by the GraphQL Code of Conduct. It's really critical that we have a welcoming environment and that everyone feels that they're in a harassment-free environment. So if you have any Code of Conduct concerns, you can find myself or one of the other organizers and talk to us. You can email or you can DM me on Discord or Twitter. I won't call it that other thing. Or if you are more comfortable, you can message one of the other GraphQL TSC members. There's 11 people, so pick one of them. You can find them on the GitHub or in the tiny URL there. So just reach out to one of them and we will get your issues sorted. If you want to stay in touch, come to the next event, and so on. You can find us at guild.host/LondonGraphQL. Please register there. Make sure you stay up to date with future events. We also have a channel on the official GraphQL Discord server at discord.graphql.org. It's the London GraphQL channel. You'll notice it because all of the other ones are named GraphQL-something, and ours is not. We're special. And of course, there is the GraphQL Twitter. We will be taking videos and photos this evening, and you are all also welcome to do so. But please keep in mind, if you've taken a photo of someone else, please make sure that you get their consent before you then share it on any social media platform or even with anyone else, really. We already have consent from all of the speakers tonight, so I definitely asked you before. So you can take photos of the speakers and share them onto social media or wherever you like during the event, like not afterwards, that's strange. And if you do so, please use the hashtag LondonGraphQL. If you fancied writing a blog post about how the meetup went afterwards, by all means, please do. And then share it with us on the Discord. That would be fantastic. We're doing something a little bit different with these meetups. We're not going to have Q&A after the talks or during the talks. So the idea is we'll break, we'll have networking time, and you can go and find the speaker and ask them face-to-face what your question is, which should hopefully give you a higher quality interaction with them and really get to the root of your question. And also gives the rest of us more time to hang out with each other and talk about the awesome technology that is GraphQL. Here is our rough schedule. So when I'm done talking to you, we'll hand over to Michael Staib to talk about GraphQL Fusion. Then we're going to have a break for finishing off any more of the pizza, talking to Michael about questions about his talk or talking to each other. About 20 to 8, we'll have Laurin do a talk for us on securing GraphQL APIs. And then just after that, we'll have Jesse's talk on Supergraph Nirvana. And then after that, we'll have a very quick closing note. And then more time to ask the speakers questions, talk to each other, and so on. And after that, 9 o'clock, we'll all be heading down to the Mook and Sons, I assume that's how you say it, pub. I won't be there for very long because of the train strikes today. I have to get a train quite quickly to get home. But hopefully a whole bunch of us will be going, so please feel free to join. We have 3 fantastic speakers tonight that have come internationally to talk to you all, you lucky lot. They are great. Nonetheless, we would love to hear from you in future. So if you have something that you'd like to talk to us about, if you have a project you'd like to show off, if you want to discuss one of the new features that are being discussed in GraphQL, if you want to share like the patterns or solutions that you have, please submit a CFP to the URL here, and we'd love to hear from you. I want to stress that we are absolutely welcoming to people who haven't spoken before, as well as people who have. So if you are new to speaking, or if you're not, but you still want some support, by all means, reach out to us. We'd be happy to give you any support that you need. We can help by reviewing your slides. We can give you advice and so on and so forth. And also, we don't just have to have traditional talks where it's like this, a bit of a lecture. You can also have like more audience participation if that works for you, or live coding. We can do lightning talks, like 3 or 5 minute talks if you just want to say something quick. All sorts of things. So just reach out with whatever you want to do, fill out the form, and we'd love to hear from you. Our next event is probably, don't know for sure, but probably going to be on the 30th of April. We're going to aim for quarterly for these events because we think it's more sustainable that way. So keep an eye on our Discord, join the guild, and you'll hear about it. And I think that's all from me. So I will pass over to Michael. Can we have a round of applause for Michael, please?
Let me quickly switch the slides. And thank you for Laurin, who is providing the laptop. Okay, so my name is Michael Staib. I'm also a GraphQL TSC together with Benji. And today I'm actually not talking about Fusion. I'm talking about distributed GraphQL and the efforts that we are doing in the GraphQL Foundation. So Fusion, actually, we presented that at the GraphQL conference last year. It was a specification for distributed GraphQL. And in the meantime, a lot has changed. So I will walk you through that. So before I dive into distributed GraphQL, let's talk about GraphQL. Who does actually know GraphQL? Anybody? Okay, that's good. Just checking sometimes. So the very amazing thing about GraphQL is that it changed how we work with things, right? We're no longer thinking about what requests do I have to craft, like we did in REST, for my consumers. It's more that we now can sync an application. So I want to build an application. So what data do I need in my components? And that it works because GraphQL introduced a very unique thing that is called a fragment. A fragment is our primitive for composition in GraphQL. It allows me to kind of formulate data contracts that I can co-locate with my components. For instance, this is a typical React component where I have here my fragment. This describes the data contract for this component, where I essentially tell or expose what data I need for this component to work. And that is great because now I'm not thinking anymore about what requests do I have or what data I want to get from a GraphQL server. I'm actually thinking about what data does my component need. And as I compose my components, as I build my application and put these components together, I'm actually building by accident something that is called the GraphQL query. So this GraphQL query, I'm not thinking about transport. There's some transport happening, but I actually don't have to actively think about that. That is basically the accident of my application. And that only works because GraphQL doesn't expose requests I can do, endpoints that I can use, but exposes a unified API. So GraphQL allows me to model the interface to my core domain. And my application components can just pick data from there. And by composing these components, I, by accident, create basically the GraphQL query. and use my business model. So I'm not thinking about requests and responses anymore. I'm actually thinking about building a proper representation of the business my company does or your company does. And that's also one key aspect here, that I just have this single API, this monolith. And if you talk to a couple of Meta or Facebook engineers, they always will tell you that the whole Facebook graph was in the beginning basically a monolith. And they served that to millions of users, 500 million users or more. And monoliths are actually, do you say monoliths? Or I don't know, so I'm a poor German guy, so if that is wrong. They are awesome. So it's awesome that you can just have this unified model where you can pick everything that you need and don't have to reflect on the fact that there could be microservices behind there or whatever. And in general, if you have a monolithic service, you have a lot less to think about. It's simple to build, right? You just build it and it works. It's easy to keep consistent. Like if you want to do changes, you can easily use refactoring tools and everything works. And it's also super easy to deploy. Just ship it. It's one service. And it's very easy to debug. But people will tell you there are a lot of downsides to this thing, right? It's slower to update, for instance. And what I mean with that is if you do a change in one piece of the graph, you may have to do it everywhere in the graph or in your service, because you cannot just introduce a new package for just this part of your overall GraphQL server. You have to do it consistently. This is a feature, but also can lead to slow adoption of new technologies. So it's less flexible, and some people will say it doesn't scale. As I said with Facebook, it actually does if you know how to deal with monoliths. Okay, so typically what people go after is actually something that is more a microservice architecture. And often the reason that they say is because of scale. And then they jump into this nice microservice world where everything is small and everything is very nice to scale. It scales indefinitely. You have full flexibility of technology. Every developer can use their own box of technology. And everything works nicely out, right? Teams can work independently and everything becomes automatically more resilient. It's not like that. It's actually a lie. It's just developers that want to adopt new technologies, right? So actually what we see with these microservice architectures, nobody knows which service does actually what. You have increased complexity of the overall system. Think about it. If every team used a different technology stack, you cannot reuse things in your own company anymore. You have to develop these base technologies every time again. Also, you have to think about things that you don't have to think in this monolithic approach, like network latencies. Suddenly you have network latencies between each of your components. You have to think about data consistency, because like in a microservice, every part of these little services owns their piece of data. If they were to work on the same database, it wouldn't make sense, right? So there's a lot more complexity that we have in these kind of approaches. So when we think about why do people go into distributed GraphQL, why do people want to have this flexibility of a microservice approach with a monolithic approach of our GraphQL system? So we have to think about concerns of separation, actually. So why do people want to separate? Often it's done because they want to slice it into business logic verticals. Like if you think about a shop API, for instance, people might want to slice it into the reviews, into the product catalog, into the account system, and things like that. And often you see people also wanting to have their own repository for all these components. So I used to work at a Swiss company like 8 years ago. And they would have, for each of their components, their own repository. They went all into this microservice madness. And we ended up with more repositories than developers. So that is, I don't know if it's healthy, but yeah, you get, sometimes people just want folders. And you have to tell them you can do a folder and then put your components in there and everything will work out. But yeah. So there are also other concerns, and they are more healthy, like, for instance, organizational concerns. That means, like, you have your organizational boundaries, teams or departments, and you want to basically divide components into these kinds of boundaries. There are also language choices, like maybe one part of the company uses C#, one JavaScript, or one Java. Like, if really every team uses their own technologies, it might not be healthy. So if you have one or two, then you want to divide, like, your development into more teams, probably. So, and then there are scaling concerns, and that is the most set reason to go into a distributed architecture, because we need to scale. So let's talk about scale before we go into distributed GraphQL, because what does scale actually mean? There are basically three vectors of scaling. We can talk about scaling data, scaling throughput, or scaling developers. So if we talk about scaling data, what most people mean is actually like having the data more distributed towards regions, so the data is closer to my customer. We talk here about partitioning or about sharding. So sharding is basically distributing our data across multiple regions, machines, disks, or files. Doesn't necessarily have to do with regions, right? It could also be just you have so much data, you need to distribute it efficiently around across multiple machines or disks. So when we talk about scaling data, it's about routing requests depending on certain discriminants to certain buckets of data. When we talk about throughput, then we're talking about a lot of requests. So there are a lot of requests hitting our system. And we got to scale, right? If we have a monolith, then we might not scale memory efficiently, because we have this big thing that lives in our memory. And if we scale that, it might be not as efficient as if when we scale something small. But I told you, like, Facebook scaled with 500 million users just fine with monoliths. So always reflect if you need to scale and if you really need to have the complexities of a distributed architecture. So when we talk about Facebook, what they essentially did is they built a GraphQL layer, a thin GraphQL layer in front of their business layer. Essentially, the GraphQL idea came from their business layer, from the ants queries and stuff. And they built a thin layer that allowed for more flexible access to the client. But when GraphQL was released to the public, the first thing what all these open source developers did is front GraphQL in front of their existing infrastructure. Basically, on day one, we had distributed GraphQL because, like, at that point in time, most people had REST services, and they took GraphQL and fronted it in front of the REST APIs, and suddenly got a much better usability of their data. Yeah. So what they discovered is, by just fronting their existing infrastructure, their complex infrastructure with GraphQL, they made the data much more usable, because suddenly they had this unified schema, and they were able to bring that together by introducing connections into their graph. And these connections also had suddenly meaning and brought semantics to the front-end engineers, because they understood much better what is happening actually with the data they have. And if you think about that, like, scaling this GraphQL monolith is not necessarily the thing that you should be worried about, because GraphQL is this thin thin orchestration layer in front of your infrastructure. So if you do one GraphQL request, it doesn't mean that you're actually doing all the work in the GraphQL server. It could also mean that you are just using a single downstream service, like the product service. Or if you do a different request, maybe you will use a bit more infrastructure. So scaling throughput, while it is a problem to scale throughput, it's not really a concern for GraphQL in the sense of we need to introduce a new specification to handle distributed GraphQL because we have necessarily a scaling problem there. So that brings us to the last thing, and that's scaling developers, or scaling our projects for more developers. That is where distributed GraphQL actually comes in. Because it's not about scale, it's not about having folders there or distributing your components into hundreds of repositories. That's not when we should think about distributed GraphQL. It's actually if you have hundreds of developers, if you have more than one team, if you're just a small startup or whatever, don't think about distributed GraphQL, build a monolith. So what is distributed GraphQL? So when we talk about distributed GraphQL, we still want to talk about this nice unified schema. We just want to formalize more the downstream services that we have. Instead of having REST or gRPC or whatever thrift services down there, we want to have GraphQL services. And we don't want to have GraphQL services there because GraphQL is better. We actually want to have GraphQL services down there because they represent part of the whole. So when we talk about GraphQL services, we talk about a composite schema that is built from something we call source schemas. Source schemas are basically a broken part of this overall schema, and it lets our developers own a piece of the graph. So each team in a larger company can own a part of the graph and can build and develop this graph without blocking other engineers. Because that's the main problem, right? If we have a single graph, doing changes to this graph might block other teams, right? And also prevent them from using different technologies. Maybe you have two languages. So, as I said, last year we introduced GraphQL Fusion, and that was a new approach towards distributed GraphQL. In the meantime, a lot of things happened, and a lot of companies actually backed Fusion back then, like AWS, IBM, the Guild. But when we put it into the GraphQL Foundation, also Apollo joined in. And actually what we did at that point in time is look at all the ideas that are out there. We took the best parts from Fusion, took the best parts from Apollo Federation, and we meshed them together. It's not a done thing yet. And that is what we call the composite schema specification. And that is the newest spec effort by the GraphQL Foundation to build an open standard that can be implemented by every company that is out there, or even open source users, to build GraphQL gateways or composition tooling in this space. This approach is collaborative. And that means that we are targeting it to exactly what I said, at companies that have this problem of a lot of developers in different teams that want to build together an overall graph. And they can now do that by splitting up the schema, and each team owns their own graph. And we can do that because the approach is composable, meaning we are introducing semantics to the type system. So meaning that in one of these source schemas could live the same types. For instance, if we have two source schemas, one is called accounts and one reviews, these are full GraphQL schemas. And we have the same type name used across these two graphs, like user is existing in both graphs. They are semantically the same thing. So basically, each of these services owns a part of this user model. So when the composition the composition is the process in merging these schemas into a composite schema, then they can do that safely and combine that to a single type. That means this is a composite type in our composite schema. It has fields across many graphs. Oh, that is not fully aligned, but anyway. Yeah, I created it today, but it happens. Okay, so in this composite graph, we have some overlaps. Overlaps are these two fields. ID and name, you can see they're existing in both graphs. So we can use that to actually optimize queries, to reduce the hops across my source schemas that I would have to do in my gateway. So the query planner actually cannot choose which graph to pick the data from, because we know it's semantically the same, so it doesn't matter which graph I ask, I get the same data for name and ID. It's semantically the same. Whereas we have other data like here, birth date and username. It's maybe his computer because he has an old version of Mac. I don't know. Mac OS. So this data, basically birthday and username, they are just existing on the account service where I have more information about the user. And then I have reviews, which actually exists on the review service of my overall web shop. The approach is evolvable, and that means like each team can evolve the schema, can evolve the types on their own. They don't have to talk about every change with the other teams. Like if they want to do a general overhaul or introduce new objects that they want to share between teams, sure, they have to talk. That's why it's collaborative. But they can evolve the part of the graph that they own on their own. So if we, for instance, introduce here a new field node, for instance, to our user account, I did mess that up, then they can just do that, and it will just merge fine. If, however, the other team has a field node which is an int, then at build time we would get a build error because it doesn't compose anymore, because we have something that doesn't align. The approach is explicit. So that means like we are not just inferring stuff from names. We are using specifications, like for instance the node specification, the relay node specification, which is used across many graphs. It's one of the GraphQL enterprise patterns that we have. We're using declarative directives that help our composition to understand the overall graphs. What are the keys? What are entities in our graph? The composite schema spec has its configuration decentralized, and I have to put that on the other side. Yeah, do that. I think you're full. Yeah, very attentive technical staff here. Okay, so the configuration is decentralized because the configuration to our composite schema is our schema. So it's GraphQL. We don't have YAML files or JSON documents that describe how we stitch. It's actually just our GraphQL schemas because we understand the semantics in these schemas. So it's declarative because I can use directives to express what keys are or what things are maybe extra available on some of these graphs. Composition is by default at build time, but you could very well, because we are defining a core spec here, you could also build a very dynamic gateway that composes at runtime. It's open, and with open, I mean it's owned by the GraphQL Foundation. So there is no vendor behind that can change the spec on a whim. So it's done in the open in a work group like the GraphQL work group, and it's owned and developed by the GraphQL Foundation. So you can trust this specification and implement it, and nobody will sue you. Source schemas in the specification can be valid on their own. The specification embraces GraphQL features and patterns like the GraphQL node specification, but also like features like a defer stream and whatnot. We're using overlapping data, so you can use overlapping data to actually do performance improvements over your overall graph. And that's typically what you have in microservices, right? You have sometimes data that overlaps to other services because you want to improve performance across your graph and reduce hops. So in short, it's an evolution of what we did with GraphQL Fusion and what Apollo did with Apollo Federation. So you could say the best of both worlds. And you can already look at parts of spec at the moment, really a very early version. So it's stage 0. So it will change in the next few months a lot. But you can participate in that work. So if you have ideas in the space or you want to work with the GraphQL Foundation in the working groups, you're invited to join and help us actually build this specification. The working group you can find here. So if you're interested, working group is available there. We are doing weekly meetings. On Thursday is the next meeting, always at 5 o'clock. Or 4 o'clock in the UK, 4 o'clock in the UK time, UTC 4 o'clock. And the specification, we are constantly working on that, is available in this repository. So if you want to join, join in. So if you want to stay in contact with me, you can do so. That's my Twitter and whatever. X. You can also X me. No, it's not a thing. Okay, and that's it.
Thank you very much, Michael. Excellent talk, as always.
Thanks.
So, yeah, talk amongst yourselves, grab some more pizza, and we'll be back here at 20 to 8.
Okay, that's good.
Before you all get settled, if anybody wants an EO4J t-shirt, just pop a signal thing under your size.
Transition.
Pull some t-shirts out for you. Just saying.
All right.
Check,
You
check,
ready?
check. Yes.
Lovely. Do you want to press the play button? All right, thank you everyone. Hope you had a nice little break. Now over to Laurin from the Guild. Thank you, Laurin. Round of applause,
Thank you for
please.
having me. So, hey, thank you for having me. Let's get this up. So, hey, I'm Laurin. I'm from the Guild. I'm from Germany. I'm an open source developer. I have a bit of a background with GraphQL. Like when I started actually programming, I started with GraphQL. From there on, I kind of became a full-time employee at the Guild, which is basically a company that does mainly stuff about GraphQL. Like we have a lot of open source libraries that are based around the GraphQL ecosystem, and lately we've also been launching our own like open source platform called GraphQL Hive for like integrating GraphQL in all kinds of workflows like schema registry, schema checks, federated GraphQL, distributed GraphQL, and all the buzzwords. But today, I'm actually the only one that's not going to talk about distributing and stuff like this. So sorry if I'm going to disappoint you. I will only be talking about the boring parts like securing stuff, especially in GraphQL. Like I'm not gonna cover like stuff like how to secure HTTP, how to do user authorization. I'm gonna mainly focus on vulnerabilities that GraphQL APIs bring us with all the benefits. So who here is like actually using GraphQL in production? Oh, that's quite cool. So first of all, I'm gonna explain, sorry for being a party pooper, why exposing a GraphQL API is a bad idea. So here on the right, left, yeah, on the one side we have a GraphQL operation, and on the other side we have like the operation result, like the execution result. But in order to like get from this GraphQL operation document to the response, a lot of stuff has to happen. And this is usually referred to as GraphQL request processing. And this can like loosely be divided into 3 parts, which is first parsing, validating, and executing, and in the end, the execution. So if we get like a GraphQL document that is sent to the server, it will first be parsed. So we have a lexer that runs over the whole string that we get, and it will transform it in some kind of like document, like abstract syntax tree, that will then be actually used by the server later on. So instead of like two traditional REST APIs, we just send an HTTP request to an endpoint. We now send a document. First needs to be parsed. Then in the next step, the parsed document will actually be checked against the GraphQL schema that we have on our server to know if we are actually allowed to execute this document, because like the document contains like selections, like which fields do we want to query, and maybe some of those fields are not even on the server. So in that case, we need to return an error and not even like execute the GraphQL operation. In comparison to like a REST endpoint, you just hit the endpoint, get your response. So we already have like 2 overheads that we need to do, like first parsing the GraphQL operation and then validating the GraphQL operation. And then only in the last part, we actually execute the GraphQL operation, like the AST thing. And this is basically executed against the GraphQL schema, or if we have like a distributed GraphQL schema, against multiple microservices and yada yada. So after we have like first an expensive parsing process, expensive validation process, we also have to create a data resolving part. We need to execute it and resolve it, and then afterwards we also need to take that data and put it into the shape that we can send back to the server. So all of these parts are basically CPU-bound overhead, and that runs in addition before we actually run any business logic on our server. And on top of that, we can execute any GraphQL document, and also the data that we load in a single GraphQL request can be complex and can cascade because we're resolving multiple relations. And those relations can like be are not predictable at the beginning. So usually all of this happens on the GraphQL API. So we have different clients that send a GraphQL query to our GraphQL server, and it is then responsible of like doing all those 3 steps. But the thing is that also anyone who wants to do us harm can also send a GraphQL query to the server and abuse all these 3 steps for actually degrading or even killing our server. So, as I just said, if you expose the GraphQL API to the public, you can create targeted attacks that affect each of those phases that I just talked about. So, one of the things that you can do is like parsing DDoS. So you just send like random random GraphQL operations to a server, but never the same operation again. You could think, oh, I'm smart. I will just cache the GraphQL operation that's already been parsed, so I don't parse the same operation twice. But will that work if the attacker sends like millions of GraphQL operations where none of the operations is the same? Will your cache even be warm, or will it always be like evicted because there's more operations coming in or not? So this can actually lead that your caching mechanism is not working at all and actually adds more overhead for your server. And then the next thing, if you come through the parsing phase and your server did not run out of memory yet, then there's also a validation phase. And for the validation phase, for each field that is in the selection set, we're actually validating whether we are allowed to query that field. And there, especially in the GraphQL JS implementation, there's one funny thing that should be like helpful. It's called like suggestions. So if you query a field that does not exist, it will tell you, oh, do you maybe mean this field? But imagine you run this kind of like fuzzy string matching for 1 million fields or something like that. Ultimately, your server will go down. And then, even if we go through that phase, then there's the request waterfall problem. So here I have an example where we have a user, we fetch those users' friends, and from those friends we also fetch the friends, and so on and so on. So for each friend that we resolve, we fetch another layer of friends, and all those will be resolved in parallel. In the end, our server will also go out of memory because we're right now trying to resolve the friends of, I don't know, 1 million records. So this a lot of shit that is kind of scary, and we can just ignore it, or we trust in the community and we come up with some solutions. So I want to talk about securing GraphQL, so I need to also give examples for like resolving this issue. So the simple solution that came up very quickly is like selection set depth limiting. And it basically means you look at the GraphQL operation, and for each layer or like level, nested level that is introduced, we increment integer or something like that. And then if we reach like a level of 10 or something like that, we just reject the operation, say, nope, we're not going to execute that. Problem with this is we first need to kind of parse the operation, so we're still like vulnerable to like any attack that's targeting parsing. Then another thing that's also vulnerable to can only be applied after parsing is like, but can actually be applied during parsing, sorry, is like tracking the count of the tokens that we already parsed while processing the GraphQL document. So the way the GraphQL lexer or like any lexer works is that it will take parts of the string and try to make sense of it, try to categorize it. Is it a field? What kind of entity for this GraphQL operation is it? And then if we exceed like a limit of tokens, we can just abort parsing altogether and just reject the operation. And then the most complex thing we could also do is like do a query complexity analysis. This is like very hard to do because you can like generalize it, because you don't know from looking at the GraphQL schema how expensive parts are to resolve. The idea of the query complexity analysis is that you, from a GraphQL operation, can calculate the score, like similar to like calculating the depth. But in addition to the depth, you also take the selected fields and based on that, calculate the score. And if it also exceeds a certain limit, you will just reject it. This is also something that some public APIs do, like GitHub or Shopify that actually expose GraphQL API to the public. So then another funny thing is a login attack that uses a mutation. So in GraphQL, you can alias fields. So if you, for example, have a login mutation, an attacker that already bypassed your HTTP security layer, whatever, will not be stopped by your HTTP DDoS layer or whatever, because you can just send like 10 logins attempts in a single GraphQL mutation, because you can just alias fields and just try to log in the same account with multiple passwords in one attempt, compared to like having to send a single HTTP request every time you want to try logging in the user. So a thing you can do here is actually like limit the amount of aliases you can set for mutation, or like maybe even in general, if you have other fields that are very expensive to resolve. And if you want to actually do something like this, there's great open source solutions available. For the JavaScript, not Java, for the JavaScript server plugin system, we have like GraphQL Armor, which Escape and the Guild, which I'm of, developed together, which works with all viable like JavaScript servers that are available right now. And also there's a new project that's called GraphQL Protect. And basically what it is like, I think it's written in Go or Rust, one of those. And it basically runs as a proxy on top of your existing GraphQL API. So all the things I just explained could be like simply added on top of any API just by running this as a proxy on top. The question is like, okay, I can apply security, but how do I know like what depth should I allow, because I already have an API and people are already sending GraphQL operations, and I have already front-end projects that have GraphQL operations defined. If I now introduce security, tomorrow like maybe half of our apps will break because they exceed the limit or something like that. So we also have this tool that's called GraphQL Inspector, and it's basically a CLI tool that it can just run above on top of your GraphQL operations. And then it will tell you like metrics like what is the maximum depth of your GraphQL operations, how many aliases are used at maximum in operation, how many directives are used, and how many tokens does the most expensive query have. So if you analyze your GraphQL operations, you can use those values for actually then applying these security measures. And last but not least, I also need to do a bit of advertisement. We also have GraphQL Hive, which is an open source GraphQL observability platform. So even if you have like random clients that send GraphQL requests to your API, you can use this tool for like seeing what kind of operations are executed against your GraphQL server, and then based on that also reason what kind of limits you want to have in order to protect your already existing GraphQL API without potentially breaking that one guy that has a third-party integration for your GraphQL API. So I already like teased that Shopify and GitHub have like GraphQL APIs, but the reason why they have GraphQL APIs is because they use it as a developer tool for us, so we can build integrations or like easily interact with their GraphQL APIs. There's also these companies that also use Graph for Taz. There's also these companies that also use GraphQL, but probably nobody ever of us sent an introspection query to any of those GraphQL servers that they're having, unless you worked at those companies. In that case, sorry. So they also use GraphQL, but we don't know how. Well, I actually know, but but they don't expose it to the public, right? Because GraphQL was never designed to be exposed to the public internet, and let me explain why. So all these companies use GraphQL, but in their internal network. And why? Because they use it as a developer tool. The way GraphQL was developed, or the reason why it was developed, is to empower front-end engineers to like write queries that fetch only the data that they need for like building UI applications. The other stuff with like federation and what kind of we are doing right now with GraphQL always came afterwards. So I'm not saying that you shouldn't do that, but we have to like think about where GraphQL comes from. And they use it in development for like writing those operations, but they will never expose these GraphQL operation documents or ship them to the client, and the client will never execute or send those strings directly to the server. So what I want to say is that we should avoid processing arbitrary GraphQL operations in production in order to make our GraphQL servers more secure. And the solution for that is trusted or persisted documents, which I'm going to explain now. So instead of like sending this HD post request where we add the query in the request body, we replace this arbitrary query or like random query that we send from the client with a hash. And then we kind of solve the problem because we're not sending arbitrary queries to the server anymore. But the process is actually more complex because first of all, we need to know all the GraphQL operations. Then we need to hash all those operations. And then we need to embed the operation hash in our front-end bundle so that the front-end or the client will only send the hash. And then the server needs to know the mapping between the hash and the operation, so it can actually, from the hash that is sent from the client, take the correct document and then execute that document. So it will look something like this. You have like a JSON file, with hashes, then you have the operations. From the web app, you just send a hash. This server will then like look up in this object what kind of hash matches which operation, take this, and then execute it. So extracting those operations and hashes is already possible with a lot of tooling in the GraphQL ecosystem. Probably the OG is like Relay. It's been doing this for years, and it's also used by Meta. And then GraphQL Code Generator, which we maintain, also supports this. And also like the new generation of GraphQL clients like Houdini also supports this out of the box. So in order to like implement persistent operations on the server, you have like multiple options. If you like use a library or like a server like GraphQL Yoga, which the guild maintain, you have a built-in solution that you can just use. But if you're using something more uncommon, you could also just put something in front, like with the other security measures that I showed for applying the persistent operation mapping, and then just forward to your actual GraphQL server that's then in your internal network. And by doing this, like, you kind of stop anyone from sending unwanted GraphQL operations. Of course, a malicious actor could still also send the hashes, but they could not send a Christmas tree or anything like that anymore. And I would even say there's additional things that you could play with, but I know at least one person here does not agree with that. So if we look at how a GraphQL request is processed, it's like when the document arrives at the server, we parse it, we validate it, and then we execute it. But if we already know the operations beforehand, we could do the parsing and the validating before, because we know that the server will be able to execute it. So we could skip all of that. And there's a lot of libraries in the JavaScript ecosystem that experiment with that. And one of them is called GraphQL JIT. And what it basically does, it takes a GraphQL document and compiles it into a JavaScript function that is like highly effective in resolving all the data for that document, compared to like having more complicated logic for on-the-fly aggregating the data sources and building the plan and executing it. And also another benefit that you get from persistent operations is that instead of sending a huge payload, like this is a very small query. I tried to fit a bigger query on the slides, but it would have looked like shit. So usually like queries become quite big, and if you just have a hash, you save a lot of upstream traffic from your clients to your server. So it makes it more efficient. So did this actually now solve all our problems? Well, there's also drawbacks of this. So this is just a simplified model, especially if we're looking at native apps. It's more complicated because we don't have one version of our native app. If you ever deployed something to the App Store, you know that there's like people using a 10 years old version of your app or something like this. So how can we ensure that like we don't accidentally break all the old clients like because we only embed like the latest hashes within our server? And the reason is that we cannot embed all the documents from all our clients, especially if we have a lot of clients within our server. It would slow down our process. We would have to redeploy our server every time we release a new app version or something like this. And it's just not convenient. So what if we introduce like an external trusted document store? It could be any database that just acts like a store where we can push stuff when we deploy the app, and then the server can, or the GraphQL API can always, like when it receives a hash, look up the hash from that store. Obviously, it also introduces some overhead because now, every time a request comes in, we have to hit the store. We could optimize it by also including an in-memory cache for the most executed hashes within the GraphQL API. But in the end, we would also introduce another attack vector that potential attackers could use to work against us. So on top of that, like if someone succeeds to kill the trusted document store, our whole GraphQL server is dead and we can't do anything because it relies on that store to function. But we can also kind of work around this by using like something like Cloudflare R2 or like S3, which can be distributed and replicated across the world. So my point that I want to bring over here is that I think that one thing that is missing in GraphQL is a better trusted document workflow for everyone. And if we look at what we have today, we have like GraphQL gateways that now are put on top of GraphQL servers. We have like the GraphQL observability platforms like Apollo Studio, our Hive, or like Cosmo. I think what is missing is also a trusted document store that is also integrated into observability platform. So you can like see what trusted documents, what app versions are still used, and based on that decide which documents can I finally get rid of, which are still relevant, and which do I still need. And I think this is something we as a GraphQL community should do at some point. Yeah. In the end, you have to decide what kind of security measures you want to take based on what you're building. If you're building a public GraphQL API like GitHub or Shopify, you need to resort to like more compute expensive measures for like securing your API. If you're building a private API that should not be exposed to the public, you need to use something like trusted documents. You could also use the other thing, but I think trusted documents in that case would be easier to implement and would have less overhead in terms of like computation power. Thank you.
Thank you, Laurin. And yes, I would agree that almost everyone should be using trusted documents. So a very, very important talk there. Also, nice reference to the 6 degrees of separation. I'm not sure if that was deliberate. There was 6 layers of friends, and I was like, that's everyone in the world, isn't it? Good job. Next, we've got Jesse from Hasura. Can everyone give Jesse a round of applause, please?
Don't forget to switch your mic on.
Is my mic off?
Is there a number? Should I grab my own?
Second YouTube.
Oh, yeah, you have to request those. Done?
Is it still live?
You should call it 10-minute.
1, 2.
You ready?
You said 20 minutes, right?
Yeah, 20 minutes-ish. 20 to 25.
Trying to go quick.
Yeah, all good?
Yeah, ready.
All right, everyone. Here's Jesse.
Here's Jesse. Thanks. So, yeah, today I'm giving you a talk about transcending microservice hell in search of Supergraph nirvana. I was deeply uncomfortable with this title that I was given until I saw that the first slide that they suggested I use was this one. I'm like, that nirvana I can do. So we're going to go ahead and work with this theme tonight, but we're mostly talking about supergraphs. Before I begin and explain about who I am, I actually want everybody here to pop open this URL on your phones because my marketing boss wants me to do that. So what we're going to do is have you answer a quick poll. My first time using this tool also. So do you have the QR code? You need it again? Come on, everybody. It says 2024. We got to like... Everybody got it? Everybody see a poll? I hope so. That's what they told me is going to happen. I don't know. All right, so reading the room. Maybe I have to hit the next button. There we go. Cool. I'm using GraphQL in production. Answer. Answers now. Don't know it, don't use it. All right, very good. That's good. It's quite fun, isn't it? All right. So we got some familiarity. More people probably are using it now, in dev at least. Side projects, very good. And Hasura, never heard of it, all the way up to running in production. I mean, if you were here for the very intro, you've heard of Hasura, so come on, everybody. Don't know it, don't use it. Boy, is today for you all. All right, I think we're probably good. Who's my running in prod person? Where are you? We're running in prod. Well, okay. We'll have a chat after. All right, and I think that was the last slide that I'm supposed to show. Very cool. Thank you, everybody. My marketing bosses will appreciate your participation with that. Moving right along to who am I? So I'm Jesse Martin. I've been in the GraphQL education space now for 6-ish years. I'm based in Germany, as you can tell from my accent. No, but I do have 4 German children, so I guess that qualifies. I'm an ex-digital strategy person, which means that I'm more familiar with like a whiteboard and a marker than I am with code. But I do have a background as a developer. I'm Motley Dev on GitHub as well as on Twitter. And I am what's called a sales engineer. Anybody heard of that role before? Any other salespeople in the room? See? We're connected. It's like destiny. Yeah. So I'm a sales engineer, which basically means I help people like you figure out how to use our product in production and make you successful. It's quite fun, actually. It's just like my ex-DevRel work, except it pays better. So, yeah. Anyways, we're going to have a talk tonight about supergraphs, and I'm really excited that we already talked a little bit about federated GraphQL because I'm going to be able to speed through a little bit because I actually have a live demo at the very end. That can really go a lot of different ways. So get ready for some participation because it is actually like a group participation demo. So it's going to be a lot of fun. But let's go ahead and talk a little bit about our agenda, a trip through time, what's a supergraph, why should I care about composability, we'll do a little demo, and then I hope that at the very end you'll feel maybe like you're missing out on something. All right, so let's talk about supergraphs and GraphQL and how best practices are changing all the time. We've heard about microservices today. Let's talk a little bit about what best practices used to mean in terms of building websites. So who here is old enough to remember this, the good old days, PHP pages, you ask the server for something, it just gives it back to you, end of story, we're done. Anybody here remember that? Good old days.
Like, that was really nice. Anybody remember these bad-ish old days of edge side includes? Anybody remember that? This whole like, well, it's mostly a server-side rendered page, but then we're going to go ahead and like actually do a direct server call and load that content onto our web pages, which was like rife of security like holes and stuff. Yeah, that was fun. What's that?
It's coming back.
It's coming back with safeguards. So like that was kind of our transition, and then we had sort of a new phase where we talked about single page applications. That was it, right? We're going to the spa. Everybody's going to go ahead and build these magical experiences, no page reloads, because that was just costing us dollars of conversion of people having to just wait that half millisecond for the page to reload. Nobody's got time for that. So instead we were going to just load megabytes and megabytes of JavaScript and call it a day. But now we start to see even newer patterns evolve now. So we're kind of coming back to server-side includes a little bit, but again with the safeguards, we have things like React Server components, or basically what we can kind of generally categorize as hydration patterns. I get the first bit of static HTML. I'm going to go ahead and ask the server to go ahead and do something else. And yeah, that's kind of what we've seen evolve a little bit over time. We went from pure server all the way to pure JavaScript, and then kind of come back a little bit to figure out somewhere in the middle. What's driving that transition for how we build things on the web? Well, API-led is a big piece of it. So we've realized that we have a lot of different places where data lives. So we've determined that we actually need to have an API for everything we own. It's pretty straightforward. REST APIs, whatever else. We're going to have something from over there come together. We have a cool experience. Data-led, because then now that we have APIs and I can have data anywhere, well then people learn that data has a lot of value. I can actually have lots and lots of data. I'm going to have warehouses everywhere. So now all of a sudden we actually have whole teams around figuring out how to invent and buy the next data product. And then data products led. So as we started to evolve to the very last step of the API to data journey, we're realizing that the data itself needs to have a whole new rethink. It can't just be we have a warehouse somewhere that's just stuffing everything. We need to actually figure out how do we think intelligently about accessing this. So this is sort of where we've seen these needs driving our adoption of these technologies. And the architecture, how we built these things, has also changed. And here's where we're going to kind of hit on some familiar notes tonight that we've talked about. Like this was the good old way. Everything in one code base. One person knew the entire thing. He was the only person that hadn't been fired yet. And that person was actually refused to leave the office because we got hit by a bus. Monolith is down, right? The only person that knew the code base top to bottom. I talked to one of them this week. It's a scary position to have. So then we went to, obviously, the solution. Microservices, which are going to save us all, right? Microservices were the way that we could break up this massive bit of code into subgroups. And then somebody said, well, microservices aren't enough. We actually need to have streaming data. We need to be able to have all these microservices that then pump everything into one big hose that we're going to then ingest at the very end and build something at the very end of it. Anybody doing like streaming architecture? I apologize. It sounds so great when you buy it. And it really has its place, but it can be extremely challenging. So what we're actually proposing about and why we're kind of trying to get to as sort of a core concept is essentially this decoupling, right? What our real goal is to have a decoupling of our API space, our data product space, and then the actual application space. So we want to be able to say that we have individual needs, internal tools, client applications, and then we have microservices. And these microservices aren't just from breaking up monoliths. They can be politically motivated internally. You could have, acquired a company, and they have a fully functional business, but you want to integrate that. And putting it into the monolith just might not be feasible. So there's a lot of reasons why this sort of architecture arises, but it's a bit of a pain. But product teams love it, right? Because you want to move really, really quickly. So I don't have to wait for this code change to go into the repository and clear all the security checks. It's easy to orchestrate my logic around. I can optimize each application individually. I can adopt React Server components here, and then I don't have to wait a long time till I have it over there. And every team owns the API and the app itself. And that's actually a really critical piece because the business owners of that individual data store understand what's inside of that individual piece, right? They get what's the actual constraints around the product. And so with these data teams, each team gets to sort of model what it means to access these data sources. So we talked about the idea of the acquisition team, right? They know what kind of things you need for authorization, what kinds of things you need to be able to, what kind of special technologies that database needs to be able to be optimized for a fancy query. If you're trying to optimize a ClickHouse query and you've been having a Postgres background, you've got very different experiences in how you're working with data. But here's where the problem comes. And I love this line here. Like, it's really true. It looks like a spider's web. And it's because it's a real tangled web. Like, everything's talking to everything all the time. Like, who's supposed to be able to possibly put an observability layer on that to be able to understand all the different chances of a data security leak? Building, operating, and scaling microservices is actually complex. Like, it's federated services is not an easy thing. That's why they're extremely well paid. So if you want to have a really good pay jump, go become a distributed engineer. And if you, I mean, it slows down in some extent because you're trying to implement this new service that you have to now expose to a whole bunch of different teams. If you're hitting the enterprise and you're scaling up, every single microservice you're deploying goes through like 10 different checks. And a microservice is supposed to be a small thing. So if you've got 10 checks from security teams for each small thing you're pushing out, it slows you down. And yeah, the product teams keep pestering for new microservices. I love that. Anybody not seen Office Space? No? Okay. Yeah, so that's a real thing. Okay. Let's talk about the rise of serverless monoliths. And this is sort of getting to the category that we're trying to pitch for with Hasura, what we think actually helps solve this problem. The idea should be that not every single thing is talking to every single thing, and you're having to figure out, okay, new team wants access to my microservice, so I have to expose a brand new API endpoint for that team. What would be really cool is if each of my individual data team owners were able to just publish their own graph that then actually kind of got vacuumed up into a top-level graph, one overall layer that actually was then shared by all the different services. So this team is able to say who has access to which pieces of data, the same as the next team and the next team, and then that actually becomes the manifest or the schema that is shared across my entire organization so that they don't have to care at all about who's consuming the actual API. All they care about is who's actually using the product. And so in a sense here, a supergraph is an architecture and operating model to build and scale multiple data domains as a single graph of composable entities and operations. Let's talk a little bit about the word supergraph because some people like to own it in the space. Anybody remember when supergraph first hit the scene as a thing in the GraphQL land? Like, this goes back to before GraphQL was even a thing. This was actually, Nick Schrock was proposing this idea of a supergraph, trying to create some reason about this new federated or single API layer for all of their different query stuff. So FQL was the thing in the day. And then GraphQL sort of evolved from this sort of level of thinking. Nick Schrock had kind of had his own way of coming at it, and then the rest of the team as well. Lee had some other ideas, and then they kind of settled on GraphQL. But Supergraph goes back a long ways of teams building out monoliths, trying to figure out how do we actually create data services that are powering this giant beast. So the idea then is that a supergraph is really essentially just a bunch of subgraphs that are connected into the top level one. I don't know what's over there actually. It just says GraphQL. Don't worry about it. So the attempts to fix the microservice challenge, we had the back end for front ends, which is something we're all familiar with. Anybody using that today? BFFs? Yeah. And then you have the federated API, which is kind of the solution that a lot of people have settled on. And then lastly, you have the operational data store, where we actually say we're just going to execute all of the actual product info on the database themselves, so like store procedures and things like that. So if a supergraph is a nice and elegant way to solve the problem, do we have any kind of constraints about what a supergraph should potentially do? Well, it should be unified and semantic. We talked about bringing semantics to entities in an organization, and GraphQL is actually really great for that. The GraphQL specification is fantastic for describing a unified way to access that ClickHouse all the way through to Postgres to wherever else I'm trying to access data. It should be composable. I shouldn't actually have to be worrying about making round trips to each service. I should be able to say, kind of going back to the shared schema concept, that I should be able to say, this is part of the graph, and that's part of the graph, and this is part of the graph, and if you have authorization for that, you actually get the whole thing brought up together. And then it should have governance built in, because obviously if you're talking about a whole bunch of different data services, I should be able to see who's accessing what, when they're accessing it, and what pieces of data are important. And then query planning and distribution execution, obviously everything has to be optimal and built into the piece. If you don't have composability, congratulations, you built an API gateway. How have we built our supergraph? So let's talk a little bit about Hasura. So we use the data loader pattern. So you get the composability piece where you actually have us doing predicate pushdowns on all the data sources. What Hasura does is I say, give it a GraphQL query, and the engine says, this is how I speak ClickHouse, or this is how I speak Postgres, and I drill down that query all the way to the underlying data sources. We even have teams in the room that are building out Neo4j connectors, which is awesome. An ability for a GraphQL query to automatically go down to those sub-layers. And it allows for a connector-first approach. I'm not actually worrying about building out specific data resolvers for underlying data sources. I'm focusing on creating an adapter pattern where my GraphQL is interpreted as a specific underlying data source. And authorization, Hasura does it for free. Has anybody here not seen Arthur? I'm hoping that most people have seen Arthur growing up. Good, anyway, good. All right, so the janitor, I do it for free. Hasura actually has authorization built in out of the box, which is one of the most powerful features, is I'm able to define on a field level access what I actually have access to. I can go ahead and put in specific RBAC or CBAC or ABAC style permissions. I had another joke there that I'm not going to actually use in this audience. It rhymes with baby, but we're not going to go there. And then we have the ability to actually see how that gets generated to the underlying permissions. So what's nice about that is instead of, especially if I'm doing a Snowflake connection, instead of me drilling down and fetching up all the data out of Snowflake, which is very expensive, I can actually do a predicate push down, only fetch the required bits of data out of the Snowflake instance that I need, and I get extremely optimal data. And then composability is included. I can actually do relations across different data sources into one unified query. That's an out of order image. Maybe I go back. Okay, yeah, so anyways. Basically, this is how it works. I write a GraphQL query. The GraphQL query goes into Hasura. Hasura says, okay, I know how to actually speak these different layers of Postgres or Mongo, and I can fetch this data out in Mongo speak and Postgres speak and actually stitch the response back together. So that gives me, I think, enough time for the demo, which is the part that I'm excited about and nervous about, but I need all of you to be part of this because I want to show you how Hasura works. What I'm going to show you is actually entirely part of our open source core product. So Hasura at its core is open source. So what you're going to see here is totally free. But I need audience participation for this big time. So here's an example of what the console looks like. And it's, this is just a way for us to be able to access the data in a nice, clean way. Everything is metadata driven, so the whole schema, the whole engine is all directed by metadata. Ignore how many icons I have at the top. It's a problem. It's really a problem. But this engine is a great way for me to be able to kind of visualize what I'm working with. But I have no API. There's nothing in here. You can see this. Everybody knows GraphQL enough to know that means no data. But what I do have is two databases connected. So I've got a SQL editor ready to go ahead and make a database connection. But we need a schema. So here's where we're going to need some group participation. Everybody knows what this is, right? We're all 2024 developers. We all know ChatGPT when we see it. So has anybody ever tried to do a Postgres schema with ChatGPT? So fun, so fun. So I need two pieces. I need a business idea, and I need a product name. So like it could be like e-commerce, and then like a business idea for the e-commerce. So I need something in the business model space. Anybody? Ticketing, travel, whatever. A marketplace. Oh, we get the whole thing right there. A marketplace for dog walkers. Let's see what the ChatGPT has for us. So I need a Postgres schema for a marketplace for dog walkers. Postgres schema is important. So we'll see. Very good. It used the word table. That's good. Yeah, we're on the right track. Yeah, so we're getting there. It likes to like tell you a lot about what it's going to do before it actually does the thing. So okay, this is making sense though. We got a users table, we got a dogs table, we got a walker profile table because you want to make sure you kind of trust who's taking Fluffy out for a walk. Appointments. This is all making a lot of sense. This is very thorough here. And then in just a minute, it's going to start spitting out some good old actual DDL for us. It's taking some time here. Nothing here is looking non-Postgres-y for the minute, so that's fine. Also, it didn't give me the code, so I'm going to say I need the code for that. Here we go. Now we start getting into the thing. All right, so it's going to start generating here. Very good. So we got the users, we got the dogs. Have you ever noticed with ChatGPT that the closer you are to the time zone when America wakes up, it starts to like just dive in performance? Like if you're in Europe, definitely ChatGPT in the morning, and then in the evening, let the Americans have it because they have a lot of questions. Okay, I think that's enough of a schema for us to be able to go ahead and get something visible out of there. Let's go ahead and copy this. I want to see if it's given us actual relations there. Did you add relations? Question mark? Okay, it did. I didn't even validate it. So we have that. Let's go ahead and pop this over into our database. Let's just see what we get out of it for free. So we're going to go ahead and run it. This is just SQL. And it seems like it executed just fine. If you look at our Postgres schema, it seems like we've got believable tables here. So again, I haven't added this to Hasura at all. Hasura is still not aware of this. What I'm going to do is go to my data tab. I'm going to add in a Postgres database. I'm going to go ahead and call this the main schema. And I'm going to bring this in from the environment variable that I've already provided. You can see a little bit, Hasura is powered by a Docker Compose manifest file. You can download this and try it out. But yeah, let's go ahead and see what happens if we add in this database. Go ahead and hit connect. And when we do that, we actually see, if we go into this tab here, that the tool has gone out, introspected, and found these tables inside of my data store. Ask me if I want to track those. I'll say yes, go ahead and track those. And then it's actually found the foreign keys between these different tables. It said, hey, this is actually like GraphQL likes relationships. Do you want to track those? We'll say, yes, track all of those, please. And when we do that, if we don't get any errors, because you never know what ChatGPT gives you for a valid schema, we'll go over to our API tab, and look at that. We have a GraphQL API that we could just kind of start to see what else we have around. So there's appointments for my dog. I can go ahead and drill down and all kinds of interesting information. But what we were talking about, how much time do I have? 6 minutes? I got it. What we were talking about is like federation, right? So this is my one data ownership team. Let's go ahead and return to ChatGPT here and ask you real quick. I need a very small schema, 6 minutes, a very small schema for a related data product to this schema, and tell me where the relationship is. All right, maybe products?
I got 6 minutes.
What's that?
You should have that. I have 6 minutes.
I have 6 minutes. So what's it telling us? It's saying, certainly it's design a simple schema for a related data product that fits into your context of dog walking marketplace. A suitable addition might be products. Table, which represents services available for dog owners to buy. So we have like a products table, relationship to the users table. So we can kind of have like the users table probably will have a nice relationship for us. So we're getting the schema here already. While we're doing that, let's go ahead and connect in our data source just to make sure that we're connected. Actually, I'll bring up my other database. I'm going to go ahead and disconnect this one, connect that one, back over to ChatGPT, see who's faster. That's a very small table, but we'll take it. Okay, so we have a products table. Do I have a... I don't think I have a very good reference there. Seller ID is going to be to users on user ID. I don't think I like that, but we'll try it out. Okay, I'm going to go ahead and put it like this. Since I don't have a users table, we're going to get rid of that references. Otherwise, we're going to have a bad day. And we're just going to go ahead and attach the user ID. So this should be fine. We're going to go ahead and run that into our database. Yes, commas are our friends. This isn't JavaScript. Trying to do SQL injection on myself. That's a bad thing. Okay, so we're going to go ahead and go over to our database, pop in the next database here. Let's go ahead and say connect database. Another Postgres one. We're going to go ahead and call this the products table. I'm going to go ahead and call this PGDB2. I'm very good at naming things. I'm going to go ahead and hit connect database. If we look at this, we go ahead and track it. Great. Now if we go back to our API, what we should see is we actually now have the products table in here somewhere. What we're going to do is make a quick relationship from this schema here. I didn't actually track maybe. No, it's tracked. Okay. Let's go ahead and go over here and make a quick manual relationship. And we're going to say that we're going to create a users relationship, and we're going to choose from this products table, so the only table I have, over to my users column. It's going to be an object relationship to the, I guess it is seller ID. Let's try it out. And that should be good. Let's see if that works. And now if I go over here to my products, we're going to get our users, which is that relationship we just created. And now I can see that I've popped back into their database now, and I'm getting the different data that I need. Actually, that's a relationship. So as you can see, that's a valid schema because there's no red squigglies. That's how I do my coding. But what we have here is a federated set of database schemas. We brought them together. I can deploy as many Hasura instances as I want, use remote schemas, event triggers on databases. I can do live real-time subscriptions. And then if I want to actually pay me money, I can do things like go to the security tab and pay for stuff like rate limiting and caching and everything that comes out of the box, and it saves you a lot of time. But if you don't want to pay me money, everything you've seen there so far is actually totally part of the free product, so definitely have a play with it. I have one last slide to give away money. Is that okay? Can I give away money?
2 minutes.
2 minutes. All right. Right here, if you go ahead and scan this code there, for new Hasura users, you can actually get, it's not very original. You can just use the promo code too. Cloud Native London 100. That gives you $100 off a pro version of Hasura Cloud. So if you don't want to do Docker, you can just sign up for Hasura Cloud. And the very, very last piece. This is the new hotness that's coming out next month. This is version 3 of Hasura. Check that out. This is how you visualize your graphs in Hasura v3. Super cool. Terso connectors, all kinds of random, really cool stuff in there. But yeah, that's it.
You didn't say it's written in Rust.
The new one is, yeah. The last one was written in Haskell. The last one was written in Haskell, and it's so fun to hire Haskell developers. So Rust is apparently where it's at now, so yeah.
Excellent. Thank you very much, Jesse. Always brave to have some live coding, especially relying on a robot, but it went brilliantly, so well done.
And ChatGPT was good too.
It was. Fantastic. Okay, everyone. So I want to say thank you again to all of the sponsors, to, if I can remember them, ChilliCream, to GraphQL, to The Guild, to Hasura, and of course, to Neo4j. If you ticked on the paper to have a t-shirt, the t-shirts are here. I understand that the smaller size is on the left and the larger on the right, so please make sure that you pick up your t-shirt if you did so. The pub that we'll be going to is Muck & Sons. If you go out the elevator, out the main door, turn left, it's just down the road on the left-hand side. Should be easy to get to. And we'd, again, love for you to submit a CFP if you would like to talk at any future events. That would be fantastic. We do have quite a number of talks lined up that will spread across the year because we're the GraphQL Foundation, so we've got lovely people from across the world who would love to talk to us. Thank you again to our speakers. You have all been fantastic, and thank you to the audience. You've all been wonderful too. Now please chat amongst yourselves.